Hello, children. Welcome back again. We are doing a chapter based on refraction through lens. Today, now we will be learning about Unit B, formation of image by a lens. This is what we're going to learn. Understand? Now, basically, it's construction. Okay, it is construction of the image, okay, of an object which is placed in front of a lens. Lens may be concave or convex. In short, we call this as ray diagram. Ray diagram. So when I say ray diagram, you need to learn and know about the different rays. Understand? So basically there are three rays which you must remember, okay, to draw the image of an object which is placed in front of a lens. Out of these three rays, you just have to use two. You just have to use any two rays to get the image or to construct the image of an object which is placed in front of a lens. Okay, so now let us learn the first ray. The first ray, okay, let me draw the two lenses here. This is my convex lens and here I have my concave lens. This is my optical center and here this is my optical center O. Now when there is a ray which is directed towards the optical center, it passes undeviated. So this applies both for concave and convex lens. So this is our first ray. A ray which is directed towards the optical center, it passes undeviated. Understand? Okay, now let's go to the second ray. Let me draw the lens. Okay, convex lens and here I have my concave lens. Now, okay, this is my f1. All right, this is my f1 for concave and this is my f2, that is the second focus for concave, and here I have my convex. All right, now a ray which is parallel to the principal axis for the convex lens, after refraction it will always pass through the focus. It will always pass through the second focus when the ray is parallel. So remember that when the ray is parallel this to the principal axis. Clear? Now for your concave lens, when a ray is directed towards the lens which is parallel to the principal axis, what happen? After refraction it will diverge out, but when you produce it backward it will appear to diverge from a point, that is second focus, which lies on the principal axis. All right, so this is our second ray. Now let me draw the third ray here on the same page. So I'm going to draw the lens here. This is my convex lens, okay, and here I have my concave lens. Optical center, this is my optical center O. This is my first focus, this is my second focus. Here I have my second focus and here I have my first focus, and this is my optical center O. Now what I'm doing is, now the third ray is the ray which is passing through the focus. So the ray which passes through the focus after refraction becomes parallel to the principal axis in case of convex lens. But if you are talking about the concave lens, a lens which is directed, okay, towards the first focus, okay, through the concave lens, after refraction it becomes parallel to the principal axis. Understand? So why did I draw the two diagrams together here on the single page? Because if you see this, okay, this number 2 and number 3 here, they are just the opposite. Here you had the ray which is parallel. After refraction it was passing through the second focus. Here the ray is first passing through the focus, after refraction is becoming parallel. Understand? Similarly here in case of concave lens, here you had a ray which is parallel. After refraction it appears to diverge from this second focus. In the second diagram, just the opposite. First, the ray is directed towards the focus, but after refraction, it becomes parallel. So, you learnt about 3 rays here. Out of these 3 rays, you can use any 2 rays to construct the image of an object which is placed in front of a lens. Okay, so before that, let's learn about kind of images which can be formed by the lens. So you all know there are 2 types of images. One is real image and the other one is virtual image. Now what are they? Let's learn. So when a ray, okay, after refraction actually meets, okay, after refraction, or you can say the refracted ray are actually meeting. So when the rays after refraction actually meets, the image so formed is called the real image, and real image can be screened. It can be screened. All right, and other one is it is inverted. Okay, the image is inverted as compared to your object. Clear? Then the second one is virtual image. When the image is formed, okay, when the rays which are not actually meeting, but these rays when produced backward, they appear to diverge or meet at a point. So the image formed under such circumstances is called virtual image, and this image cannot be screened. It cannot be screened. Understand? Clear? So these are the 2 types of images which are formed by the lens for an object which is kept in front of them. All right, now let's learn about the construction of the images. Okay, construction of ray diagrams of a lens. Okay, now for this, what you are going to do is you are going to draw a straight line, mark one point here. Okay, is that okay? So we are learning for the convex lens. First we will learn with the convex lens. All right, so what is it? It is the image formed by convex lens. All right, so here what are we actually doing is we are trying to locate the formation of image. So location, and we will write the nature of the image. Okay, so see, let me erase this diagram first. So why are we drawing the ray diagram is to know the location of the image and the nature, what kind of image is going to be formed. So that is our main motive to draw the lens, the ray diagram. Okay, so for this first what I will do is I will draw a straight line which will now act as a principal axis. So we are doing a convex lens, so I'll mark a point first, then I'll mark another point here approximately 2 centimeter. Now another one more point which is at a distance of 2 centimeter, one more point, and ultimately one more point here. So here you see that I have drawn 1 2 3 4. So the one which is at the center, this is the place where I will draw my convex lens. So here this is my optical center, this is my first focus. Here I have center of curvature, that is twice of first focus. Here I have second focus, and this is my twice of second focus, that is 2f2. Is it okay? Yes. So now let's see the first one, case 1. Now what is the case 1? When the object is at infinity, it's very far away from us, so we do not know where the object is. Understand? So at that circumstances, what will happen? The rays coming from that object will be parallel to the principal axis. So I have a ray like this. Understand? So now you know I have a ray which is parallel to the principal axis, and as I've taught you that the rays which are parallel to the principal axis, after refraction it will pass through the second focus. It will pass through the second focus for the convex lens. So it is actually meeting at a point. Yes. So see, first of all we must know location. So where is the image formed? On the second focus. Now let's learn about the nature. Now rays are actually meeting, so it is real image. So the image is real. Are you getting my point? Yes. Clear? And here the image will be inverted. Okay, I will show you how it is inverted. Okay, understand? Now here you see that my object was a large object here, but now you see that it has been diminished to a point, means ghatekocha, isn't it? So it is diminished, the size has been reduced. So these are the three natures of the image formed. Image is real, image is inverted, and image is diminished. Right? Now I'll show you how it is inverted. Now if these rays, okay, were not parallel to the principal axis, okay, understand, but the rays were parallel to one another. All right, okay, let me change the color of my pen so that it becomes quite understandable. So I have one ray here, I have another ray, so these two rays are parallel to each other. So after refraction, what will happen? It will meet at this point. So here, this is the formation of the image. Understand? So here you see that the image is inverted because it is forming below the principal axis. So whenever the rays are meeting below the principal axis, the image form is inverted. All right, so this is our case 1. Now let's learn case 2. Case 2, what does case 2 says? Case 2 says when the object is beyond the twice of f1. So let us do like this: when the object is beyond 2f1. all right, so as I said you, I'll draw a straight line. I'll mark the first point which will act as 2f1. okay, I'll mark the second point 2 centimeter f1, third point again at a distance of 2 centimeter, that will be my optical center. One more point at a distance of 2 centimeter, that will be my second focus or second focal point, and here I have my fifth point which will be my twice of second focus. So at the center I'll draw the lens, a thin lens. This is my optical center. So what does the heading or the case says? The object is beyond 2f1. So let me change the color. So I will keep my object like this. So see that the object is always marked with a arrowhead on it. So this arrowhead is the head of the arrow mark, is the head of the what? Object. Okay, object. So now I will name this my object. So A, B. So you should see that the object should be always placed on the principal axis and its base should always touch the principal axis. So here my AB is my object. AB is my object. AB. Understand? Now how do I start the rays? Start the rays always from the tip of the object. So I'll first use my first ray. The ray is parallel to the optical center. As I said you, principal axis. As I said you, the ray which is parallel to the principal axis after refraction will pass through the second focus. So please remember this and use ruler. Understand? If you do not use ruler, what will happen? You will not get a perfect result. Now as I said you must draw two rays, or you must use two rays to get the image formation or to form the image or locate the image. All right, so the second ray I'm going to take again from the tip itself, and I'm going to pass it through the optical center. So I am passing it through the optical center. So when a ray passes through the optical center, it passes undeviated. And do not forget to put the arrow head. So here you see that they are intersecting. So the point at which the ray intersect is the point where it is formed. My object image is formed. So this I will name it as A dash, B dash. So I'll write here that A dash, B dash is my image. Yes, so I located, isn't it, the image where the image is formed. Now I'll write the nature of the image. Nature of the image formed, or I can write here characteristics. Okay, number one, the rays are actually intersecting, actually meeting. Yes, so when the rays are actually meeting, it's a real image. So image formed by the rays which are actually meeting, or the refracted ray which actually meets or intersect each other, then the image so formed is called real image. So here the first nature I can write as the real image. Second one, it is inverted. Now compare the size, it is diminished. घटेको छ. Yes, image object यत्रो थियो, image के भयो अलिकति सानो भएको छ. So these are the three characteristics of the nature that you will write. Okay, now after this you must also know where this kind of lens is used. So uses, so it is used, okay, as a camera lens. Is that okay? It is used as a camera lens. Okay, now let's learn case 3. See, you can pause, you can rewatch again if you are not able to catch up. Okay, now case 3. When the object is at 2f1, principal axis 2f1, f1 first focus, optical center second focus, twice of second focus. This is the place where I draw my thin lens. Now I must keep the object on the 2f1, so I'm keeping my object here, A, B. So I'll write AB as the object. I will now take the first ray from the tip which is parallel to the principal axis. After refraction, it passes through the second focus. Okay, now the second ray that I'm going to take is the ray which is passing through the optical center. Okay, so it's a little bit crooked, passing through the optical center. It passes undeviated, right? Is that okay? Now this is the point of intersection, so my image is formed here. So A dash, B dash. So A dash and B dash is my image. I will locate the image in this way. Now I must write the nature. Number one, the rays, the refracted rays are actually meeting here, so the image formed is a real image. Number two, it is inverted. And number three, image size is same as the object. So you can put a star mark here. So when do you get the size of the image equal to the size of the object? When you keep the object where on 2f1. Alright, so after this you learn about its uses. Where it is used? It is used in a telescope. Okay, terrestrial telescope. Understood? So important, you can mark a star on this case number 3. Alright, now let's move to case 4. Case 4. Now case 4 ma chai where see you can see that in the first case the image was very object was very far away from us, infinity. Now it is nearing to the lens. In the second case it is beyond 2f1. Now in the third case you saw it is on the 2f1. Now obviously it has to shift little bit towards the lens, so now it will be between f1 and 2f1. So here fourth case will be when the object is in between f1 and 2f1. okay, so let me draw the lens. This is my 2f1, this is my f1, this is my optical center. Here I have second focus and here I have twice of second focus. Please make sure that the distance or the gap is or are equal. So I must keep my object where between 2f1 and 2f1. so I'm going to keep my object here. So my object is a b, so I'll write here ab is my object, right? So the first ray that I have to take, the first ray is parallel to the principal axis. After refraction it will pass through the second focus. Same thing. Second ray pass through the optical center. Yes, it passes undeviated. Yes, it passes undeviated. Let me extend a principal axis a little bit. So here now I will get here, this is the point where I get my image. So it has b dash is my image. Understand? Yes. Now let's write the nature of the image formed. Number one, it's real because the rays after refraction, these two rays are actually meeting here, so the image is formed by the actual intersection of the refracted ray. So I can write the image is real, so it's a real image. Number two, it is again inverted, see. And number three, if you size the compare the size of the image with the object, it has enlarged, isn't it? So I will write enlarged, or I can write magnified. Clear? So you just see, it's every time we are just using the same two rays. A ray parallel to the principal axis after refraction passes through the second focus. Second ray that I'm taking is the ray which is directed towards the optical center. It passes undeviated. यहाँ जहाँ भेट्छ intersect गर्छ, that is the point where my image will be formed. Now image is formed by the actual intersection of the rays, refracted rays, so it's real. See, it is, the image is formed below the principal axis, so the image is inverted. And compare the size. So compare this size, the object size, and image size. Image size is greater as compared to the object size, so it is magnified. Then where it is used, that is application. Application भनेको यो प्रकारको लेन्स त कहाँ युज गर्छ? So it is used in cinema halls as well as in your projectors. Okay, so in your smart class, when you were having offline classes, you have seen during the online during the smart classes, isn't it, the projector used to project the image on the screen and a big image used to come. So that is the application. Okay, now let's go to the case 5. So now we are now nearing to the lens, isn't it? Yes. So now we'll keep the object where at f1. So for this, let me draw the lens. So I have 2 f1, here I have f1, then O, here I have f2, then I have twice of f2. This is the point where I will draw my lens. I am now keeping my object here. So A, B. So A, B is my object. Yes. So as usual, I'll take two rays from the tip. First ray will be parallel to the principal axis. After refraction, it will pass through the second focus. Alright. Second ray, I'm going to pass it through the optical center and it passes undeviated. Now you see that these two rays are not meeting, so we do not know where the image will be formed. Understand? So what here we'll consider about the nature is that the rays are going to meet at the infinity. So when they are meeting at infinity, it is going to give you real image. Understand? Number two, since the rays are going to meet below the principal axis, so image will be formed as inverted image. And number 4, it is going to meet at infinity, means a huge and large, like the ठुलो image is going to formed, isn't it? So we will write highly magnified image will be formed. So this will be the 3 characteristics of the image formed by the convex lens when the object is kept on or at first focus. Understand? First focus ma राख्दाखेरि. Right. So you saw that when we have the object at infinity ma राख्दा के भयो, then we kept beyond 2f1, then we kept on twice of f1, then we kept between 2f1 and f1. Now here we kept on f1. Now let us keep between this optical center or the lens and first focus. That is will be our case 6. Now case 6 is when the object is at, or you can write between f1 and optical center, or you can call it as lens. Lens ra first focus ko beach ma राख्दाखेरि चाहिँ what will happen? Let's see. So I have my principal axis. This is 2f1. This is my f1. This is my optical center. This is my second focus, and here I have twice of second focus. I'm going to draw my lens here. This is my lens, okay, and I'm going to keep my object between the first focus and the lens, that is optical center. All right, now what I'm going to do here is I'm going to pass or draw the rays, 2 rays from the tip of the object. So here you see that the ray which is parallel to the principal axis, after refraction it will pass through the second focus. All right, now the second ray that I'm going to take is a ray which is passing through the or directed towards the optical center. It passes undeviated. Understand? Now you see that these 2 rays are diverging away from each other, so they are not going to meet, isn't it? But when I produce it backward like this, they will appear to meet. So here somewhere here it is appearing to meet. So I'll draw a dotted image. So here I'm drawing a dotted image just to represent you all that this is the image A dash B dash. This is my A and this is my B. So I'll write here A B as my object and A dash B dash is my image. Clear? So here you see that this is a very unique situation. Case number 6 is a unique situation when you see that the refracted rays are actually not meeting. So the nature of the image so formed, number 1, you can write that it is a virtual image because the rays are not actually meeting, but when you produce it backward they are meeting here. Understand? So till now you saw that our convex lens it was always giving you real image. But this is the situation, a very special situation, when the convex lens is giving you virtual image. So lots and lots of questions can be asked from this particular case. Understand? And every year, if you see past 10 years question, you will see that a question has come from this particular case. It's a very important case, unique case, because you see that this is the only situation when the convex lens gives you virtual image. Number 2, you see that the image formed here is above the principal axis, so it is erect, isn't it? पहिलाको 5 वटा केसमा चाहिँ image was real and image was inverted. यो दुईटा थियो नि त एकदमै, हैन? जहिले पनि जाम भइराको त्यही real and inverted. But here you see that it is virtual and erect. Understand? And number 3 is that it is highly magnified. It is magnified. So these are the 3 natures of the image formed. So you can put a star on this. It's very important. So when do you get real and virtual and erect image from a convex lens when you keep your object between the lens and the first focus र lens को बीचमा चाहिँ object राख्यो भने चाहिँ you will get image which is virtual and which is erect. Okay, understand? So now learn the uses. It is used as a reading glass, okay, or a magnifying glass, or a simple microscope. Is that okay? Is that understood? So these are the 6 cases. Out of these 6 cases, very 2 important cases were your case number 3, when the image size was equal to the object size, and this case number 6, when the image is virtual and erect. Okay, so this is the 6 diagrams which you have to learn for convex lens. Okay, now for the concave lens, you just have to learn one diagram, just one diagram. Okay, so let me draw a concave lens here. So I have a concave lens here. This is my second focus, this is my twice of second focus, this is optical center, this is my first focus, and this is my second focus. Now see, wherever you keep the image object, this is AB is my object for concave lens. So concave lens ko jasuकै अगाडि राख, whether you keep beyond the here I have kept beyond 2f2, whether you keep it on 2f2, okay, or where you keep on f2, or between here, wherever you keep, you see that the first ray which is you are taking, which is parallel to the principal. Let me change the colors to make you understand. A ray which is parallel to the principal axis, okay, it will appear to diverge from the second focus. The second ray that I'm going to take is the ray which is passing through the optical center. So this is the point of intersection, isn't it? So this is where my A dash B dash, that is my image, will be formed. A dash B dash, this is my image formation. So wherever you keep your object, every time a concave lens is going to give you this kind of ray diagram. That is your nature of the image, that is it's virtual, because you produce this ray, because you have produced this ray in the backward direction, so it's virtual image. Okay, number B, image is erect. Okay, and number C, it is diminished. You can compare the size, isn't it? Size of the image with the size of the object. Yes, so these are the 3 characteristics. All right, yes. Now who or where do you use, or you must know the application of this lens. It is used as in a spectacles. Okay, the person who cannot see the distance object, so the short-sighted person will use this kind of lens to rectify their eye. Okay, so you just have one case 1 for your concave lens. Okay, so these are the 7 important ray diagrams. Okay, out of this 7, 6 is for your convex lens, and this last one is for your concave lens. All right, so you have a table on your book. In your book you'll get table where the relative positions of the object in the image in case of concave lens and convex lens is given. Go through that table as well. Okay, understand? So that's all for today. Thank you.